Have you ever looked up at the night sky and wondered how many of those tiny, twinkling lights have planets circling them? For most of human history, we could only guess. The planets in our own solar system were our only known companions in this vast cosmic ocean. But today, we know of thousands of other worlds called exoplanets, orbiting distant stars. The most amazing part? We found the vast majority of them without ever seeing them directly. It's a grand game of cosmic hide-and-seek, where the clues are written in the language of light and gravity. Imagine a firefly buzzing around a colossal searchlight thousands of miles away. The star is billions of times brighter, drowning the planet's faint glimmer. So instead of the planet, astronomers watch the star for subtle changes in light or motion. The most successful planet hunting technique is beautifully simple. It's called the transit method. Imagine watching a distant streetlight. If a tiny moth flies in front, the light dims for a moment. Astronomers point telescopes like NASA's Kepler and TESS at thousands of stars, measuring brightness with precision. They wait, sometimes for years, for a planet to pass between its star and us. This transit creates a tiny, temporary dip in brightness, the shadow of an unseen world. Depth of the dip tells planet size. Bigger worlds block more light. Timing and repeats reveal the orbital period, the length of a year on that world. Starlight filtering through the atmosphere can show gases like water vapor, methane, or carbon dioxide. Limitation: it only works if the orbit is edge-on from Earth. Many systems are missed simply due to orientation. It's cosmic chance. Despite that, over 75% of known exoplanets were discovered by transits. Transits revealed hot Jupiters, rocky super-Earths, and multi-planet systems. Planets are common. They are the rule, not the exception. Before we found planets by their shadows, we found them by their gravity. The radial velocity or wobble method. A planet and its star orbit a common center of mass. The star makes a tiny dance. When the star moves toward us, its light blue shifts. Away from us, it red shifts. Same Doppler effect as a passing siren. Periodic shifts in spectral lines reveal the planet's pull. This gives a planet's minimum mass. Stronger wobble means more mass. In 1995, it found 51 Pegasi b, the first planet around a sun-like star. Best for massive, close-in planets. Small, wide-orbit worlds are hard to detect. Tiny tugs can drown in star noise, spots and flares. If seen face-on, motion is side to side, not toward away. The wobble is invisible to this method. Here is where things get truly strange, straight out of Einstein's playbook. Gravity bends space-time. A star, even a planet, can act like a magnifying glass. Gravitational microlensing. If a foreground star passes in front of a background star, it focuses the background light. We see a brightening, then a fade, with a distinctive shape. If the lens star has a planet, its gravity adds a short, sharp blip, a planet's signature. It relies on gravity, not planet light. It can find cold, distant planets, even free-floating rogue planets. It is sensitive from giant Jupiters down to Earth-mass worlds. But it needs a rare, perfect alignment: source star, lens star with planet, and us. The event happens once and never repeats. We get one shot, valuable for the census, hard for follow-up. From watching shadows to catching stellar wobbles, our methods are creative triumphs. Transit counts shadows. Radial velocity measures a gravitational dance. Microlensing uses the universe as a lens. Direct imaging is hardest of all. Masks block starlight so telescopes can catch the planet's faint photons. A true portrait. Transits give size. Radial velocity gives mass. Together, they reveal density. Rocky world or gas giant. We are measuring, characterizing, mapping new worlds. Much of the universe is hidden, but it whispers in light and gravity. Remember the thousands we know, and the billions we suspect are out there. The invisible is becoming visible, one planet at a time. The universe is waiting. What wonders will we find next? Subscribe to our Universal Universe channel for daily cosmic adventures, and don't forget to share and like the video.